The Home Pros Radio Show.
I'm Tommy Donovan with RIC Home Inspections, and this is the Home Pros Radio Show podcast. The home building industry is constantly evolving the ways in which we manage the efficiency of our homes. Efforts to lower the costs of our utility bills and make our homes environmentally friendly have brought about changes in the materials and methods we use to insulate our living spaces from the extreme heat of summer and the harsh cold of winter. We may upgrade things like our attic and floor insulation, but did you know that in order to get the most out of these improvements, we need to consider what may need to be done to other aspects of our home, like the way we caulk and weather strip our windows and exterior doors? And what about the separations between our living space and our attics, basements, and crawl spaces? Also, don't forget about your HVAC ductwork. These are all components that make up the system that we call our home's thermal envelope. Brett Hovis with A-1 Insulation joined us on the show to emphasize how changes to one part of the system often requires changes to the others, and as we learned, if not done correctly, we could actually be doing more harm than good.
This is the moment we bring in our buddy Brett Hovis with A-1 Insulation. Good morning, Brett.
Good morning. How are you?
I'm doing fine. There's a lot to learn about insulation. You think it's a simple thing. People think they know it's just stuff that you throw up in the attic and then throw your Christmas stuff on top of whenever you move in. What are the different types of insulation that are out there that we commonly find in our attics?
Probably the three most common would be fiberglass, whether it's a batt or a blown-in, which is also referred to as loose fill. Then cellulose is very popular, blown-in cellulose product in the attic. And then spray foam as well, which typically you would see spray foam in the rafters up against the sheathing, right against the roofing deck. Within the walls, those three are primarily pretty common as well. Again, a fiberglass batt. There's several different applications for a product like cellulose in the wall. You can have similar to a bib system where it's blown in dry, or a stabilized, which is the wet application. Mm-hmm. And then you have the spray foam as well, and whether it's in the wall assembly or, in the attic. So those are the three major types that we see. Depending on the age of the home, you could see some older insulations as well, such as like a rock wool or a vermiculite.
You said the key word. That leads us to
the RIC Home Inspections photo from the field.
What are you looking at? I know what I'm doing.
Did you see that? So we're talking about fiberglass, cellulose, wool, foam, mentioned vermiculite. And that, ladies and gentlemen, is what we saw on the RIC Home Inspections photo from the field. That would be the answer to what we had posted. Basically, the vermiculite is something that kind of looks like, small little rocks, shiny rocks, if you will.
Yeah, gravel. Typically, it was only installed with, 3 to 4 inches of it.
I got a question about that. How heavy is that? Is it as heavy as gravel? Is it lighter? Sort of like, say, lava rock or something. How some different ones are lighter. Is it as heavy or no? No,
I mean, it does. It has some weight to it. That's one of the reasons that, you don't go and put in, say, 10 to 12 inches of it,
stack it up.
You see in the photos, it's like barely maybe a half inch.
Yeah, but I just sit there and think about the weight of gravel on your drywall in the attic, and I just wasn't sure how. I didn't know if it was lighter than gravel or if it was actually the same weight.
Well, yeah, and one thing that's important to talk about with vermiculite is that there are some potential hazards with it. Tommy and I talked a little bit about this, and that. Really, if that's something that you see in the attic, we really need to have a professional look at it. Back in I think it was the 70s, a lot of the vermiculite came out of Montana, out of a mine out there where, according to the EPA, a lot of that material, there was asbestos in it. So there is a risk of that. If you look at the Facebook picture and you think that's what you have in your attic, I would highly recommend calling a professional to look at it and evaluate it. You definitely don't want to disturb it. Let somebody come out and take a look at it.
Yeah, don't just go up there stirring up the air real good in your attic and stirring the asbestos dust around.
When it comes to asbestos, that's the big thing. If you suspect anything in your home does contain it, just leave it as it is. Mm-hmm. Best thing you can do is not touch it at all.
It doesn't bother you sitting there. It's when it gets stirred up and the dust is floating around.
Get the fibers airborne, especially with vermiculite. Start mixing it around.
Oh, yeah.
And it may not have it. It's just important to know.
That's important to know, yeah. Right. Yeah, is that, if you do suspect anything like that, just because you see it there doesn't mean it is asbestos. I see clients, home purchasers do that a lot. Well, is it asbestos? Well, we don't know. In fact, we had Dina Lopez, a realtor with Berkshire Hathaway, give her a little plug. She actually responded and said, hey, is that asbestos on the Facebook page? And I was like, no, but I knew what she was thinking.
Yeah,
it's
yeah.
vermiculite. But see, even that is a perfect illustration of how people see vermiculite and go, oh, it's asbestos. Right. But it has to do with its origin.
Right. Yes.
But we were going to talk about building science and insulation's relationship to that. So tell us, how does insulation work?
Insulation is mainly measured in R value, which is resistance to heat transfer. So the three major things that you want to keep in mind when regards to insulation are conduction, convection, and radiant heat. Conduction is obviously the insulation in your wall and attic to help slow down the heat transfer from coming into the home. Convection, think of a convection oven where air is moving through it, and radiant heat would be through the sun, which the only way to truly stop radiant heat would be like with a radiant barrier in your attic.
And we've talked about that on the show before, how heat moves through a home through those main processes: conduction, convection, and then through radiant methods. Which of these is insulation directly related to?
It goes to all three, really, but depending on what type of insulation that you have, it could change. For instance, fiberglass insulation will mainly only stop conduction of heat. Then you get into some of the other types of insulation like cellulose or spray foam that will help with conduction as well as convection.
So we're talking about how we want to actually slow the movement of heat and air between the outside of the home and the inside of the home. We want to talk about certain terms, like, for example, the separation between outside air and inside air in our home we refer to as the building envelope. And there's a difference between the building envelope and the
thermal envelope.
Tell us what the difference between those two are.
Well, the main difference, the building envelope would be the entire building assembly, basically what you could see from the outside of the home. The thermal envelope would be the area that's going to be conditioned space in the home.
And that's usually where we're putting this insulation we've been talking about.
That's right.
Yeah. And when we're talking about air movement in our homes and keeping our homes efficient, we want to think of the home as an entire system, which we want to consider where that thermal boundary is.
The Building Performance Institute, they estimate that roughly about 30% of your utility costs could be directly affected by air movement through the envelope of the home. So some other things to keep in mind when looking at the energy efficiency of a home is like we've already mentioned, the air movement, but then also HVAC plays a major role in that. The age of the system, the efficiency of it,
how well the ducts are sealed,
exactly, the quality of the windows and the doors in the home, and then again how well the home is air sealed, the efficiency of the insulation. Again, not all insulation is created equal, so it's important to know what the quality of the insulation is in the home as well.
And when we're talking about that, we're concerned with R value or R factor. What does that mean?
That's right. Well, I mean, again, the R value is it's a measurement of the thermal resistance of heat transfer
through that particular material, right?
That's exactly right. The one thing that's important to keep in mind about R value, though, is that it's all relative. These are tested in a laboratory in ideal conditions. As you guys have seen and being in the field for a long time, very seldomly do we go into environments that are an ideal.
I've never seen that.
Right, exactly. So
that's why we have home inspectors.
And so it's important to know that R value is a number. And an example I'll give you would be with a fiberglass bat. Anywhere that there's a compression in the bat, meaning that it's not touching all six sides of a wall assembly, it changes the efficiency of that R value of. They roughly estimate about 20%. So if I've got an R13 bat, which is standard in a 2x4 wall, that has a lot of compression issues with it when it was installed, then it might be more like an R8.
So that includes, like, say, plumbing pipes.
Exactly.
Okay. Yeah. See, because when you said that earlier, I didn't even think about those things. I was just thinking if it didn't extend all the way to the wall, all the way to the floor, to the ceiling, the drywall, the studs, the six sides.
Right.
But I didn't even think about that because there's very few walls in the exterior of a house that don't have something, whether it be an electrical wire or a plumbing pipe or a gas line. I mean,
exactly.
Yeah, if you've ever been to a house when it's being constructed, there's pretty much something in all those walls.
Mm-hmm. And that's not to say that fiberglass is bad, but that's where it's important to know that there's steps that if you choose to insulate your home with fiberglass, say in new construction, where you take proper measures to air seal around those areas to help with that. Again, going back to what we mentioned earlier, that air movement,
whole system,
exactly, and the air movement is what is driving a lot of that. Mm-hmm. So, and then that's where also a lot of the newer materials have gained a lot of traction. Spray foam, stabilized cellulose in wall cavities they stop conduction, but they also stop convection of that air moving through it. So you can still air seal, but you can know that your insulation as well is going to help stop or slow down that convective loop through the wall assembly.
So we were talking earlier about how conduction is commonly thought of when we're talking about slowing heat movement in a home.
Right.
And that's why you want your insulation, folks, fluffy. We want it to look nice and thick and fluffy because that air that is created in that envelope within the insulation is what slows the conductive movement of heat through that. Right. If you have compressed insulation or missing areas, that's when you go in and you add more. Now, we've talked about thinking about our homes as a complete system. With air movement, then this is where we get into convection and convective movement of heat. Air leaking out of our home, we call exfiltration.
That's right.
Air coming into our home that we don't want is infiltration. Exfiltration occurs, air leaves our homes, and then what results in our home? A negative pressure.
Right.
So makeup air has to come from somewhere.
Right.
So when we're talking about air leakage and air movement in our home, we kind of want to think about makeup air as where's the air going, and then where is it coming from? So are there good sources and bad sources?
Yes, there are. Any house has to have fresh air coming into it. If not, it can be a hazard to your health with indoor air quality. Mm-hmm. In new construction, a lot of times now, according to the Building Performance Institute, they want to have zero negative air coming into a home. Their motto is that it be airtight and ventilate right. So in a situation like that, we would actually bring in mechanical ventilation through your HVAC system, which is fresh air.
Their philosophy is basically to err on the safe side. I love it.
We'll be here for another 20 minutes, guys.
It looks like we've got Ed from Morganton on line one. Scout's letting us know. Did you say you have a question about spray foam?
I heard you guys talking about fiberglass insulation having the fluffy factor. Mm-hmm. Because spray foam isn't fluffy per se, how effective is it as far as breathing, from inside, outside air, if you know what I'm saying?
Good question.
Insulations like spray foam are going to do a better job of stopping convection, that air moving through it. Again, a lot of times now in building science, they're more focused on making the house completely airtight, and then using mechanical ventilation to help the home breathe.
But can't you make a home too airtight? I mean, so it's sealed up more than it actually should be. Isn't that equally as bad as not having enough insulation in a home?
You're thinking just like I do, is I'm like, well, don't we need, if we're letting the air come out, if we're making our home too tight and the air does get out, the makeup air's got to come from somewhere. I mean, you've got to have that happen. That's just the way the world works. So it makes you wonder, is there such a thing as being too tight? You're improving your insulation or you're sealing up your windows. What about what Shane mentioned earlier, which is like those penetrations in your flooring system where the electrician or the plumber drilled holes to run lines, and if those aren't sealed, or let's say our ductwork on our HVAC system is not sealed tightly enough, we could be actually drawing in bad air, and that's when we get into air quality. We get mold and stuff like that in the house, right?
Exactly, and we have to think of this in two different ways. You have to think of older construction, and then you have to think of newer construction. In new construction now, with the 2009 IECC, which is the code compliance, every house, for instance, where we're at in South Carolina, has to have a duct blast test done before a home owner gets their certificate of occupancy. But there's also other ways that we can do blower door testing as well, where with what Tommy's talking about, the blower door test, we run that to look at how many air changes per hour are happening in that home. In new construction, again, we can make the house as tight as we want to, and then we can go in and have fresh air coming through the HVAC, the fresh air intake, and make up for the air instead of having a negative pressure. What's important to know is that a lot of us, myself included, have older homes. You can't just go out and buy every tube of caulk that they have and start sealing up all these penetrations in your home before you understand the effect of doing that. And because what you could end up doing is causing more problems for you in the future, with the home not being able to breathe, not enough air, fresh air coming into the home, and it can run risk of with your combustion appliances, if you have gas appliances in the home, the negative pressure.
It causes backdrafting and things like that to occur.
Exactly.
Carbon monoxide hazard.
Exactly. Carbon monoxide hazards are a big thing. It's very important to look at it, as new construction versus old construction. Mm-hmm. And there are tools that we have to be able to test that out. If you're changing more than about 15% of anything in the home, whether it's insulation or doing air sealing, I highly recommend to do a blower door test to see what the effect of the work that you've done to make sure that you haven't created a potential hazard within your home.
So basically, what it is the newer construction has the makeup air based on the way the house is being built tighter anyway.
Exactly.
So if you go in and take an older house and try to make it tighter without adding the makeup air that is needed to keep it balanced, you're creating a problem.
That's right.
I got you. I was just trying to run it through, the way I'm processing it.
Exactly.
But yeah.
I hope that answers your question there, Ed. Does that make sense?
It does very, very well.
All right, name some of these areas. So you're talking about a blower door test. Basically, you're depressurizing the house. You're blowing air out of the house. So tell us about the process of determining where those leaks are.
Yeah, so when we do a blower door test, essentially what we're doing is depressurizing the house to 50 pascals. It's roughly a 20-mile-an-hour wind on all sides of the building envelope or the house. So then what we have tools that we can use. We can use a pressure pan. We can use a smoke pen. You can simply use your hand as well and go to different areas of the home, different penetrations. For instance, an electrical outlet or HVAC supplies and returns, and you can use those tools to figure out where the majority of those leaks are coming
leaking
from.
into the house.
According to the Building Performance Institute, about 30% of the air leak locations within a home are simply located in the floors, walls, and the ceilings. Mm-hmm. Those are your common areas.
Places
again,
like attic hatches.
Your can lights that are going into the attic. But yeah, those are the big.
So those are areas that you want to make sure that you check.
For more, you can find A1 Insulation on Facebook, where Brett regularly shares photos and videos of his jobs in progress. You can also reach A1 Insulation by phone at 864-506-4098. We'll revisit this topic again in upcoming episodes of the Home Pros Radio Show, where we'll get into more detail about blower door testing, and we'll even share ways that you can actually conduct your own test to see how efficiently your home is circulating air. Be sure to follow us on Facebook and Twitter to stay up to date on when this will happen. Just look us up at Home Pros Radio on both Facebook and Twitter. Of course, you're guaranteed not to miss a thing if you simply hit the subscribe button for this podcast. Also, do you have a topic you'd like to cover? Send us an email at ask@homeprosradio.com and we'll make sure it's covered. Until then, I'm Tommy Donovan with RIC Home Inspections, and I'll look forward to being with you again next time on the Home Pros Radio Show podcast.
Thank you for listening to the Home Pros Radio Show. If you have a question for the Home Pros, visit us online at homeprosradio.com, where you can contact us directly and also learn more about the topics and guests we bring to you each week. It's the Home Pros Radio Show online at homeprosradio.com or on the radio at 94.5 WGTK, The Answer.